This is Mrs. Frazier, and we are working through your test review for slope and rate of change in direct variation. Number one, this occurs when there is a constant rate of change. Well, when there's a constant rate of change, we have a linear relationship, C. The change in Y can also be referred to as my vertical change, so B. The change in X can be referred to as my horizontal change, D. And the ratio of vertical change to horizontal change, so if I write it as, in this case, change in Y over change in X, that's referred to as my slope. So this gives me an actual measurement for the steepness of my line. And another name for slope is rate of change. Other vocab words to know, Other vocab words to know are direct variation and constant of variation. So remember, direct variation is another name for a proportional relationship. And constant of variation is the name for K, or unit rate. It's my slope in a proportional relationship. Describe the vertical change and the horizontal change between the 2 points. So looking at my vertical change, I always read my graph from left to right. So I should see that if this were a line, okay, so a linear relationship, I should see that my line is decreasing. So my vertical change is decreasing by 1, 2, 3, 4. So my vertical change would be -4. And my horizontal change, 1, 2, 3, 4, 5. So again, I look at my vertical change, or my change in Y, as -4. And I look at my horizontal change, or my change in X, as 5. So if I were to write this as a slope, I could say m equals -4/5 as my slope. Number 7, show how you can use 2 different size triangles to calculate the slope of the line. Justify your answer using the slope formula for both sets of points. Okay, so let's look at my 2 different size triangles, how they can both help me find the slope. Well, first I can see that my line, if I look from left to right, is decreasing. It's falling, so this is going to be a negative slope. I know that regardless of the size of my triangle, I should get the same calculation for slope. So I can see that my rise is 1, 2, 3, 4, 5, 6, 7, 8 for my larger triangle. And actually it would be -8 because it's a falling line. And my run is 1, 2, 3, 4. So as a slope, I have -8 over 4. I can get the same value by actually utilizing my point. So if I look at point Q is located at -3 and 3. And point T is located at 1 and -5. So remember, if I want to find the change in my Y, I'm looking at how I get from 3 to -5. So using my slope formula, which is on your formula chart, y2 minus y1, x2 minus x1. I'm going to subtract my second y minus my first y. So negative 5 minus 3. And then I'm going to take negative 3 minus 1. And what this should give me is the slope I've already calculated. So negative 5 minus 3 is negative 8. Negative 3. Oh, and see, I did this wrong. I need to fix that. I accidentally did x1 minus x2, and I need to do x2 minus x1. So I need to do 1 minus negative 3 equals 4. So negative 8 over 4 is negative 2. So this is just another way to verify, which is the same as my negative 8 over 4 here, that I have the same slope. It's just another process to find slope. But we need to be able to recognize all of these and how all of these go together. Okay, so looking at my smaller triangle, the rise is negative 4, and the run is 2. So again, rise over 1, run, negative 4 over 2, and that's going to give me the same value as before, so negative 2. So here we are looking at 3 different ways to verify that I have the same slope for all of those triangles, and no matter between what 2 points, I should end up with the same slope, no matter which way I do it. So m equals negative 2. Number 8, the table below contains 2 points of a linear function. What is the slope of the line? So again, I'm going to continue and I'm going to look for the rise and my run. So if I look for my rise, I'm looking at the change in my y. So I'm looking at how we're going from negative 3 to negative 1. So my rise is plus 2. And then my x value is my run. So I'm going from negative 0.5 to positive 1. So I'm increasing by 1.5. So I write this as rise over run, so 2 over 1.5. And this isn't very pretty, but I can actually manipulate this a little bit. I'm going to multiply both of these by 2. And I'm actually going to get 4 over 3. So this would be my simplified slope. But say this was one of my answers, and this was, I could actually change this to a decimal. And when I change it to a decimal, I get 1.3 repeating. And then when I'm checking my other answer choices, this also gives me 1.3 repeating. So that would give me the same answer either way. So that's a way for me to check my work. Number 9, the table shows the time in hours and the number of people that passes through a toy shop. What does the slope of the situation represent? Okay, so first we need to find the slope so we can think about what it represents. So I'm looking first at my number of visitors and how that's increasing. So sometimes I get nervous about all of the decimals. So if they give me more options, I actually just kind of skip over those. So I'm going to skip from 50 to 200. And I can see that I'm increasing by 150. So this represents my rise or the change in my y. And now I have to use the same point on the other side. So I'm going to go from 1 to 4. So the change in my x is plus 3. So let's think about what this is. This is 150 visitors. And this is 3 hours. So I'm going to write this as a slope, change in y over change in x, and I'm going to think about what this means. It's 150 visitors every 3 hours. So if it's 150 visitors for every 3 hours, what would that be for 1 hour? So I'm going to simplify this, and I should get 50 over 1, or I can just write it as 50. So it's 50 visitors per hour. Number 10, the following table shows the value of a property within a 4-year time. By what value is the property increasing each year? And what was the starting value of the property? Now, the starting value is not where 1 is. That's after 1 year. So the starting value would actually be where 0 is. And this is a little bit extra step, so this won't be on your test, but I'm going to go over it anyway. Because I actually do think that you could do it, but it won't be on your test. But first, let's look by what value is the property increasing each year. Well, let's see. From year 1 to year 2, it's increasing by $6,000. And same with years 2 to year 3 and year 3 to year 4. So it's increasing by $6,000 per year. So if it's increasing by $6,000 per year, if I go back a year, before it actually did any increasing, I should see that it would go back. So I would lose $6,000. So that means I would have $100,000. So my starting value is $100,000. Again, this piece won't be on your test yet, but this one will. So you need to see that my rate of change or my slope is $6,000 per year. Okay, number 11, what is the slope of the line represented by the values in the table? Express the slope as a ratio. Okay, so remember, slope can be found between any 2 points. So I don't have to deal with negatives if I don't want to, but I always like to look and verify. So like here I can see this is a change in y of 3, and this is a change in x from -4 to -2 of 2. So again, we write it as change in y over change in x, which is 3 over 2. But I'm going to verify down here with my positive points. So from 12 to 15, I also get +3. I also get +2. And these don't have to be the same numbers, but they do have to simplify to be the same. So I may have gotten some different numbers, but they may have simplified. But I can see again that I get 3 over 2 more than once. So that would be my slope. Riley is selling lemonade. She is earning a profit of $5 for every 20 cups of lemonade. Riley's friend Kylie wants to make the same profit per cup of lemonade, but she plans to sell 30 cups. How much money will she profit if she is profiting at the same rate? Okay, so let's start with Riley's 20 cups of lemonade, which we know costs $5. So I'm going to organize that into a table. So if she's selling 20 cups for $5, I want to know how much she's selling for 1 cup. So I'm going to take that $5 and I'm going to break it into 20 pieces, the 20 cups of lemonade that she sold. And I should get 25 cents or 0.25. So she's charging 25 cents for 1 cup. So if Kylie sells 30 cups at the same rate, the same price, how much would she sell? So I'm going to take 30 and I'm going to multiply by that 25 cents. So remember, 20 cups was $5. And when you do that, you should get, when you multiply that out, you should get $7.50. So 30 cups would be $7.50. Number 13, if y is directly proportional with x and y equals 25 when x equals 15, what is the value of y when x equals 75? Write an equation that could be used to represent this relationship. Okay, so let's set up our table of values and what we know. So I know x and y, and I know that they're proportional. And I know that when x is 15, y is 25. I know in a proportional relationship, I'm going to have k, or I'm going to have a unit rate. So y equals kx. And I'm not adding or subtracting anything. So that's going to help me when I write my equation. And I'm looking for the value of y when x is 75. So let's find x when it's 1 so we can find out what it is when it's 75. So we're going to find our unit rate. So we're dividing by 15. When you take 25 and divide it by 15, you should get 5/3. You might get 1.6 repeating, but let's keep this as a fraction. So our calculators will do that for us. So let's keep it as 5/3. Okay, so now we're going to take 75, because I know 1 is 5/3, and I'm going to take 75, and I'm going to multiply by 5/3. You should get 125. Okay, so 125 is my y value. But to write my equation, let's think about what we did. Well, we actually took 75, our x value, and multiplied by 5/3, my unit rate. So if I were to write an equation, I'm going to write my equation with my unit rate as my k value. So y equals 5/3 x. Number 14, based on the graph, how many sodas will the employees consume after 10 days? Okay, so here's my days, and I can see it stops at 5, so that's not real helpful, and I can't even see what 5 was. I could see what 2 is, so at 2 days, it is 80. I can also see at 1 day, it's 40. I can also see at 0 days, it's 0. So what I have is a proportional relationship here, or a direct variation. That means I also can have a unit rate. So my k value, or what y is when x is 1. So here's my unit rate here at 40. So k equals 40. That means I can also have an equation of y equals 40x. So at 10 days, if k is my unit rate, 10 days I can just do 40 times 10. Because if it's 40 for 1, for 10, it would be 400. So 40 times 10 is 400. So it would be 400 sodas in 10 days. Number 15, state whether the following slopes are negative, positive, 0, undefined. Then calculate the slope of the line. Okay, so I can see on this first one that if I look from left to right, my line is increasing. It's going upwards. It's rising. Okay, we always look left to right. So this is a positive slope. So finding my rise, it's increasing by 1, 2, 3. And finding my run, 2. So I'm going to write my slope as change in y over change in x, or rise over run. And I get 3 over 2. Okay, my next line, I can look from left to right and I can see that it's falling or decreasing. So this is a negative slope. So when I look at my rise, I should see that it's going down, but it's okay if I don't, as long as I remember that my slope is going to end up being negative. So I could just count this as 1. And I'm going to count this as 1, 2, 3. So 1 over 3, but since it's negative 1 over 3. Or negative 1/3. Again, we still wrote this as change in y over change in x, or rise over run. Okay, on this next graph, I can't rise any. Okay, I can't go up any. But I can run. So I can look from point to point here, and I see 1, 2, 3, 4, 5. But my rise was 0, and my run is 5. And if I put this in my calculator, 0 divided by 5, I'm actually going to get 0. So my slope here is 0. This is different than the next one. So that one was a horizontal line. But if I look at the next one, I have a vertical line. And for this one, I can find a rise if I just put a point anywhere. 1, 2, 3, 4, 5 is my rise. But my run, I can't go left or right, so there is no run, so 5 over 0. And if I put this in my calculator, I'm not going to get 0 like I did before, but I'm going to actually get undefined, or UNDEF is what your calculator will say. So this is an undefined slope. Number 16, Julio's wages vary directly as the number of hours that he works. If his wage for 5 hours is $45.50, how much will he earn in 30 hours? Use your knowledge of direct variation to solve. Okay, so remember, direct variation just means a proportional relationship. So vary directly just means that they are proportional to each other. So 5 hours is $45.50. Let's find our unit rate of 1 hour. So I'm going to take $45.50 and I'm going to divide it by 5 to get to 1. So 45.50 divided by 5 is 9.10. So he's earning 9.10 per hour. That's my unit rate. So now I can take this and figure out how much he's earning for 30 hours. So now I'm going to take my 9.10 and I'm going to multiply 9.10 times 30 for 30 hours. And when you multiply those, you should get 273. So for 30 hours of work, they're earning $273. Number 17, determine if the tables are linear or nonlinear. If the tables are linear, find the rate of change. Okay, so this is a little bit of a review from a previous year. On your test, you're not going to be tested on linear or not linear. But remember, in the vocabulary, a linear relationship is going to have a constant rate of change. So I need to check to see if my rate of change is constant. So looking at my first table, I can see it's increasing by 6 for every 3. So 6 over 3. And then it's increasing by 4 for every 2. So 4 over 2. And these are both, if I simplify one, I would get the other. So they simplify both to the same thing. So I'm going to continue. Here, if I increase by 8, and 4. So this would be 8 over 4, which still simplifies to 2. And then I have 4 over 2, and again simplifies to 2. And then I have 2 over 1. So again, 2 over 1 also simplifies to 2. So this would be considered linear. And also, I can see if the most simplified one is actually what my rate of change is. So 2 over 1, or I could actually say my slope is 2 or my rate of change is 2. Looking at the next, I can see from 10 to 7, it's decreasing by 3, and x is increasing by 3. Okay, so as a rate of change, that's negative 3 over 3. For my next points, it's decreasing by 3, but my x is increasing by 1, so this is negative 3 over 1. So immediately you should see that these do not simplify to be the same. They're not equal. So this is not linear or non-linear. Okay, so the next one, I can see my y is not increasing at all. It's 0. And my x is increasing by 1 each time. And that's the same all the way down. So I can write this as 0 over 1, and I get 0. So this is a linear relationship. If you remember from the previous page, this would actually be a horizontal line. So it is linear, and my rate of change or my slope is 0. Number 18, assuming that y varies directly with x. So in other words, they are proportional. What will the value of y be if x equals 25? Write an equation that represents the situation. Okay, so I have lots of x values here and lots of y values. The one that I look like that drew my attention is that I want to know what y is when x is 25. And I know what y is when x is 10 and 6 and 4 and 2. And this is the one that I went to. Because if I know what y is when x is 2, 2 and 5, then I should be able to write what it is for 1. So 2 and 5, well, to find my unit rate, I'm going to divide by 2. 5 divided by 2 will give me 2.5. And then I just need to know what it is when it's 25. So I'm going to take in that 2.5 and multiply by 25. Okay, so my equation for the situation is y equals 2.5x. Remember, my unit rate goes right here. Okay, so now I'm just going to multiply 2.5 times 25. And you should get 72.50, or 72.5 is fine. Okay, calculate the slope of the line and interpret its meaning. Okay, so looking at my graph, I can see that I have a graph that passes through the origin. So this is a proportional relationship. And if you remember, we learned that slope is the same as unit rate in a proportional relationship. So if I look here, 80 and 2 would make 40. And here, 80 is my miles and 2 is my hours. So 80 miles for every 2 hours would mean it would be 40 miles per hour. So my slope is 40, same as my unit rate, 40, and it represents 40 miles per hour. Number 20, calculate the slope of the line and interpret its meaning. So here my slope is not in a proportional relationship, so I can't just go here and 1 and find my point here. That's not my slope. So I'm going to find my rise and my run. So my rise, I can see it's decreasing. So it's going down 3. Make sure you pay attention to your scale. And here it's referring to inches. So my candle length is going down 3 inches. So I'm going to actually write myself a note here. Minus 3 inches. That's my rise. Now our run. It's increasing from 0 to, let's see, to 30. So you can see here these are going up by 0, 10, 20, 30. So it's decreasing 3 inches, and let's see what the 30 stands for. Every 30 minutes. Three inches every 30 minutes. So I can write my slope. I can simplify this a little bit. If it's a slope, it's negative 3 over 30, which would be negative 1 over 10. So in simplest terms, again, let's think of what the minus 3 was, the minus 3 inches. So this would be minus 1 inch. So the slope represents decreases 1 inch, and the 10 represents the minutes. So decreases 1 inch every 10 minutes. And then actually to write it as a slope is negative 1 over 10.